In addition to what we've looked at so far, which I would call monatomic ions, which means single atoms with a charge, single atomed ions, there is a group of what's called polyatomic ions. Poly means many, many atomed ions. These are just groups of atoms with a charge, more often negative, but occasionally positive too. And these, unfortunately, are super common in chemistry. Now, if you look at these lists right here, like here's fluoride and there's iodide. So fluorine to fluoride, iodine to iodide. But wait, there's cyanide. Cyanide is a polyatomic ion. It has a C and an N, and those two come together to have a -1 charge. So cyanide is not carbon or nitrogen. It's both of them together with a -1 charge. Here's hydroxide. We're going to talk a lot about hydroxide. Hydroxide is an O with a oxygen with a hydrogen and a -1 charge. Hydroxide is really common. And there's a bunch of these. Here's acetate. That's one that we'll run into quite often. NO3, -1 is nitrate. So a nitrogen, 3 oxygens, and a -1 charge. Permanganate is fairly common. Carbonate, carbon, oxygen, 3 oxygens, and a -2 charge. Phosphate on the bottom. There's lots of these, gang, and you've kind of got to know them. Notice here how the darker black kind of bolded ones are what they consider here to be more common. All right, that's somewhat accurate, somewhat inaccurate, but still it's a place to start. In a face-to-face class, I will, depending on what you're taking right now, I would give you quizzes or exams where you'd have to know/memorize these. And I do encourage you, regardless of your learning situation, to kind of commit these to memory. We're going to run into them all the time, and not having to look up nitrate is NO3 -1 is going to take a lot of time. Even with the powerful Google, you're still going to have to type it in or voice it or whatever mechanism you use for Google and stuff. So it's really cool to memorize them. In the old days, I would use a flashcard. On one side of the flashcard, I would write nitrate, and on the other side of the card, I would write NO3 -1. So you need to know the name, and you need to know the types of atoms and the charge associated with it. And if I was waiting for the bus or something like that, or waiting at my friend's house, I would just flip through them. Kind of, this is what I did then. They, of course, have flashcards now online. You can look at on your phone or your computer and stuff like that. But the more time you spend with this, the better. They're going to run into to them quite a bit, I'm letting you know. Here's a little bit more thorough list. And there's lots and lots of these, as you can see. One of the few positive ones is NH4 with a +1. It's called ammonium, and ammonium is related to ammonia, which is NH3. I told you to know/memorize ammonia in a previous lecture. Ammonium is also important. You can see that there's like a +1 hydrogen connected to ammonia to make ammonium, or you take away that H+ to make ammonia from ammonium, either way. But anyway, this is just a little bit longer group. In the Chem 221 nomenclature lab, that's the definitive list, if you will, of polyatomic ions to know/memorize. There are a gazillion, nice science word, I know, but there's literally a ton of these crazy polyatomics out there. And again, the more familiar you are with it, the better. And so this is a good reference. The one in the lab is a better reference. Please make sure you know about that. Down here is a note. If you see something that ends in ATE or ITE, that usually means that it's an oxygen-containing anion or an oxygen-containing polyatomic ion. So if you look, like here's ATE phosphate, all right? Here's 8 in nitrate and also ite in nitrite. So 8s and ites usually, all right, mean that there's an oxygen in it. There are some exceptions, but that's a pretty good kind of overview of some of these. So that's another little hint here to figure things out. Which of the following polyatomic ions probably does not contain contain oxygen. Okay, so remembering earlier how the ates and ites, if you see that ending, that usually means that you've got oxygen. So phosphate, that's got ATE at the ending, that's got oxygen. Hypoiodite is the next one, but it has an ITE ending, probably going to have oxygen. Selenate, ATE, you bet. Nitrate, ATE, you bet. But cyanide. Cyanide does not have an ate or an ite ending. So like we talked about earlier, cyanide is CN-1. There's no oxygen in it. So again, often an ATE or ITE ending or suffix indicates oxygen. Phosphate is phosphorus with oxygen. Hypoiodite is an iodine, I atom, with oxygen. Selenate is selenium. Nitrate would have nitrogen, but cyanide does not have any oxygen, no ATE or ITE ending. Another way to learn the polyatomic ions is to use the little expression related to Nick the Camel. And the expression is, Nick the Camel brat ate icky clam for supper in Phoenix. And you're like, okay, that sounds pretty disgusting. And you're probably also like, what exactly is the purpose of this, Dr. Russell? And I totally understand. It is an acronym. And each of those phrases, Nick, camel, brat, icky clam, supper, Phoenix, has a meaning. Now, a consonant in the English language is not a vowel. And the vowels are A, E, I, O, U, sometimes Y. So if it's not A, E, I, O, U, it's considered a consonant. So notice here in Nick, you have three consonants. N, C, and K are not vowels, but it does have one vowel. So the number of consonants equals the numbers of oxygen, and the number of vowels is the charge. So Nick has three consonants. It's got three oxygens. The I is the single -1 charge, and the N is the nitrogen of nitrate. So nitrate is NO3 -1. Now, camel has three consonants, C, M, and L. It has two vowels, A and E. So C is carbonate, carbon with oxygen, all right? That means CO3 for three consonants and a -2 charge because of the two vowels. And you can keep going through and see how all of these work. If you want to go really crazy, maybe Nick had crepes for dessert. Crepes is chromate, another one we'll run into sometimes. Now, this is totally an optional thing to use. Some people love Nick the Camel, and some people think it's really silly. And I don't care which camp you're in, right? You can think it's cool or silly, and I'll still am very pleased to have you in my class. However, if it does help, this is something that has been useful in the past. Check it out. Little practice with it, and it will rock you pretty well. But again, I was always more of just a memorization person with my flashcards. But anyway, I'm nerdy chemist, so what do you expect? Here's some examples of the importance of polyatomic ions. Nitrate is NO3 with a -1 charge. And we're going to see that nitric acid, which maybe you've heard of before, which is a real common and powerful acid, is basically nitrate with an H+. And acids oftentimes have an H+, maybe even two H+s connected to them. So nitric acid loves to get rid of that H+, and this is the acidic hydrogen, by the way. And when it does, it makes nitrate. So nitric acid and nitrate are related to each other. There's a lot of nitrate in the world. There is quite a bit of nitric acid, but not as much of nitrate. Nitric acid loves to give up the H+. So acids will have this hydrogen, which is acidic. And notice that this hydrogen is listed first. That's a way to show other chemists the importance of that hydrogen because it's acidic. Other examples of this, NH4 we saw was ammonium, all right? And NH3 we saw earlier was ammonia. And this is another important combination you've got to know about. Now, ammonia, NH3, reacts readily with water to make ammonium hydroxide. Now, ammonium hydroxide has the ammonium, NH4+, as well as a hydroxide. Hydroxide is another polyatomic ion. So it's easy to go from ammonia to ammonium, or ammonium back to ammonia, if you know what you're doing. And it's another thing that shows the importance of acids, the H+. Adding H+ or taking away H+ makes one or the other. But for right now, the important thing, ammonium is one of the few positive polyatomic ions, or cations, we're going to look at. And it is different than ammonia. Ammonia, you have to add an acid, H+, to make ammonium. Here's some other ones. Phosphate, PO4, with a -3 charge. Phosphate shows up a lot in biology. Acetate, which is used for lots of things, is a CH3CO2-1. This is the picture of acetate. This is the CH3. Here is the CO, and then this is the O- part right there. It's the acetate. Finally, on the right side, you've got sulfate and sulfite. And I put these up here because the ATE, polyatomic with an AT ending, that's the most common form of sulfur with oxygen. Sulfate is actually pretty common. And sulfate, sulfur with 4 oxygens and a -2 charge. However, you do run into, or people will use in their day-to-day life, the version with 1 less oxygen, which is called sulfite. So you can see there going from sulfate to sulfite, it's basically 1 less oxygen. You still have the sulfur central atom, you still have a -2 charge, but sulfite has 1 less oxygen than sulfate. And this is a common kind of a pattern you're going to see. Sulfate, sulfite, 1 less oxygen. Now, phosphate and phosphite are also compounds that exist. Phosphite, if you were going to make it, that would be PO3 with a -3 charge. Same charge, by the way, -3, 3 minus, same thing. Same central atom, phosphorus, but this one then would be phosphite. PHIT. Sorry, my pen doesn't work sometimes super well. So phosphate, phosphite, 1 less oxygen. So it's not that it means that 8s always have 4 or something like that, or the charge, it's a relative reference. Explore this a little bit, you'll see what I mean. Nitrate and nitrite, similar kind of things. Again, same central atom, nitrogen, but 8 more than ite. So 8 has 3 oxygens in this case, and ite has 2. Notice on the last examples that phosphate, phosphite were 4 oxygens to 3 oxygens. The 8 to ite just means you have 1 less oxygen. It doesn't mean you start with 3 or 4 oxygens. You have to know more about it. And that's where Nick the Camel thing pops in. On the bottom here, we've got another way. This is the blue box is the 8, and that's the most common of the polyatomic ions with that central atom. And as you remove an oxygen, you go to the ITE. So chlorate, you can see in the kind of bluish box, goes to chlorite. Now, once in a while, you can even have 1 less oxygen. So if you take away 1 oxygen from chlorite, you make hypochlorite. So notice the chlor part in the middle is the same here. You're just going chlorate to chlorite to hypochlorite. And once in a while, you can add 1 more oxygen to the common form. And chlorate plus 1 more oxygen would be ClO4 -1. That still has the chlorate base, but you put a per in front of it. So perchlorate would have 1 more oxygen than chlorate, while chlorite 1 less oxygen, and hypochlorite 2 less oxygen. On the website or the companion, if you have it, there's a common polyatomic ions and their corresponding acids handout. It talks more about Nick the Camel and also how you can relate Nick the Camel to acids. And I do recommend that you check that out if you have nothing else better to do. Try not to shoot the instructor, all right?